Number 5 says a spherical balloon is inflated with air at the rate of 10 cubic feet per minute. How fast is the radius of the balloon increasing when the radius is 5 feet? Well, first let's write down the volume of a sphere. So the volume formula that we'll be using is 4/3 pi r cubed. And we're given the information that the balloon is inflated at the rate of 10 cubic feet per minute. So that means that the volume is increasing at this rate, at this constant rate. dV dt is equal to 10. Now we're asked how fast is the radius of the balloon increasing. So we want to know what is dr dt when r is 5. So remember how we do these problems. We start with the eliminate step if we have more than one variable over here. If we have 3 variables, we only have 2. So we don't need to do that step. And then we go to the differentiate step. So let's do that. The differentiate step will give us an equation containing dV dt and containing dr dt, which is what we need. So let's go ahead and differentiate with respect to t. So on the left side we have dV dt. On the right side, bring down the 3 r squared times dr dt. That's our implicit differentiation, or our a little chain rule over there. Okay, we can cancel these. So here's dV dt, 4 pi r squared dr dt. So now we're ready for the substitute step. We substitute in the constants only at the very end. Okay, so we're ready for that now. We're going to substitute in dV dt equal 10 and r is 5. All right, this 10 and this 5. So we have 10 is equal to 4 pi, r is 5 squared dr dt. Okay, so 10 is equal to 4 pi times 25 dr dt. And just divide, and we have 10 over 100 pi is equal to dr dt. And just cancel here, that's 1 over 10 pi. And our units would be feet per minute. Number 6 says sand is falling off a conveyor belt onto a conical pile. Okay, so we're talking about a cone. Let's write down the volume of a cone. V is equal to 1/3 pi r squared h. Okay, back to the problem. Onto a conical pile at the rate of 20 cubic feet per minute. So that tells us that dV dt is equal to 20. The diameter and base of the cone is approximately the diameter of the base of the cone is approximately equal to the altitude. Okay, so the diameter is equal to the altitude. The altitude is h, and the diameter is twice the radius. So we have this little equation, 2r is equal to h. That's the little side equation that's going to enable us to get rid of a variable. At what rate is the radius increasing? So we want to know dr dt equal question mark when h is 10. So which variable should we eliminate? All right, so we're going to start with the eliminate step. But here we're asked to find dr dt, but h is mentioned as well. R is mentioned and h is mentioned. Well, we can easily figure out when h is 10, we can figure out what r is. Let's just do that. So just when h is 10, see we have this little equation over here. 2r is equal to h, or r is equal to h over 2, just switching it around. So when h is 10, r is equal to 10 over 2, which is 5. So we want to find dr dt when r is 5. So, okay, so basically we're interested in r, and therefore we want to eliminate h. All right. So whatever derivative we want to find, we want to find dr dt. That's the variable that we're interested in. Okay, so we're interested in r, so we want to eliminate h. Let's just write that down. That's what we're doing in this step. We're eliminating h. Here's our little equation that tells us what h is equal to. All right, so here's our volume formula. And instead of h, we're just going to put 2r. So we have our volume is equal to, I'll write 2/3 pi r cubed. Okay, that's the eliminate step. And now we're ready to differentiate with respect to t, and then we're going to have a formula that has dv dt in it and dr dt, and we'll be able to get the information that, figure out what dr dt is. All right, left side we have dv dt is equal to 2/3 pi, differentiate, bring down the 3, r squared, chain rule, dr dt. Let's just cancel these 3's. Let's write dv dt is equal to 2 pi r squared dr dt. So now we're up to the substitute step. That'll enable us to figure out dr dt. Well, what were we given? We were given that we want to find dr dt when r is equal to 5, and we're given that dv dt is equal to 20. Okay, so let me just rewrite this. So that's 20, and r is equal to 5. So let's substitute that in. 20 is equal to 2 pi r squared. That's 5 squared dr dt. 20 is equal to 50 pi dr dt, and we get dr dt when r is equal to 5. Just divide over here, so we have 20 divided by 50 pi is equal to dr dt. Let's write that as 2 over 5 pi. And let's see, what is that? The units, let's go back up, and we have feet per minute. So that would be feet per minute. Number 7, we have another related rate problem. So it reads, a ladder 10 feet long is leaning against a building. So let's draw that. So that's the building. There's the ladder. The bottom of the ladder is being pulled away from the building at the rate of 3 feet per second. So here's the bottom of the ladder, and it's being pulled away. If we call this distance x, and this distance from the top of the ladder to the bottom of the building, if we call that y, that means x is increasing at the rate of 3 feet per second. So let's write that down. dx dt is equal to 3. And here we're asked how fast is the distance from the top of the ladder to the ground changing. All right, so that's dy dt. How fast is y changing? What is dy dt? When the base of the ladder is 6 feet away from the building, when x is equal to 6. So first, let's write down an equation that relates x and y, and that would be the Pythagorean theorem. Y squared plus x squared equals 10 squared, or 100. Now we only have 2 variables, so we don't have the eliminate step. We're going to go straight to the differentiate step. So let's do that, the differentiate step. That'll give us an equation that contains dx dt and dy dt, which is what we want. So let's do that. So we have 2y dy dt plus 2x dx dt is equal to 0 for the derivative of the constant 100. Let's divide this whole thing by 2. Y dy dt plus x dx dt is equal to 0. So now we're at the substitute step. All right, we want to find dy dt, solve for dy dt, when x is equal to 6, and we're told that dx dt is equal to 3. So we're going to put 3 over here, and we're going to put 6 over here. We're just missing this y, but when x is 6, we can figure out what y is using Pythagorean theorem again. So let's do that. Let's do that over here. First, when x equals 6, we have y squared plus x squared plus 36 is equal to 100. So we have, subtracting 36, y squared is equal to 64, so y is equal to 8. All right, so now we can substitute 8 right here. And now the only thing, oh sorry, not right there. We'll substitute our 8 for y right here. Now the only thing left is dy dt, and we'll solve for that. So let's do our substituting now. 8 for y, dy dt, that's what we're going to solve for, plus 6 times 3 is equal to 0. So we have 8 dy dt, that's 18, is equal to minus 18. All right, and just divide, and we have dy dt is equal to minus 18 over 8, or minus 9 over 4. And I think that's feet per second. Just a minute. Or let's see what it is. Yes, feet per second. Right, that's feet per second.